Good day. You are welcome to this channel once again. This channel is Zion Tutor, where we bring science subjects like mathematics, further mathematics, physics, both Cambridge syllabus and WAEC syllabus. The question under them, where we bring simplicity to it for our students to understand it, to comprehend it, and for them to be able to retain it in their mind. Today we are talking on what we call a projectile motion. Or before we proceed, please, if you are a returning subscriber, we love you, but please, if you are new to this channel, please don't forget to press the subscribe button so that when we draw any new video, YouTube will notify you. And please help us to share it to every student that you know, and this channel can be of help too. Today we are moving to projectile motion. If you check our last video on physics, we do something we call both upward motion, downward motion, and horizontal motion. Now the combination of these three is what we refer to now as a projectile motion. So that means projectile motion comprises of what we call upward motion, what we call downward motion, and what we call horizontal motion. That's the combination of those three is what we refer to as projectile motion. As the definition we have it, we know a projectile motion is a motion of an object in a parabolic path, and the path of a projectile is what we refer to as a trajectory. The question that we are trying to solve today is a Cambridge question. It's like a man standing with an arrow and try to shoot an arrow, and this is the target for the arrow, but the center of that target for that arrow is this point. The center of the target is this point. So when the man shoots that arrow, it shoots it at an angle of 4.30 degrees, and the height above the ground is 1.66 meters. From the plane where the man shot the arrow to this plane, the distance that we refer to as our horizontal range, that is the horizontal motion. The distance, which is our range, is 70 meters, and the initial velocity of the arrow is 65 meters per second. Is 65 meters. You can see this is the ground. The distance or the height above the ground is 1.66 meters. Now the question now is telling us to find that we should show that the time taken for the arrow here to hit this target is 1.08 seconds. The time taken for the arrow to hit this target as 1.08 seconds. And you know, in our projectile, when we are talking about the time of flight, the time of flight is the time it takes this arrow to leave this projected plane. This is the projected plane, and to return back to the same projected plane. But as you can see here, the arrow hit this target. But one thing that we know about the projectile motion, since we have our horizontal distance, R is 70 meters. So in getting our time of flight from the horizontal distance, is our horizontal distance is equals to the horizontal component of our velocity times the time of flight, and that time of flight is signified as t, the horizontal component of our velocity. And how do we get, since the velocity is projected with an angle, so let's just resolve that now. The horizontal component of our velocity, that means my ux will be equals to u cos theta, and that will give me what's the u is 65 times cos 4.30. If we punch that in our calculator, that means my ux will give me 65 times cos 4.30. Sorry. Okay, now 65 times cos 4.3 degree cos 4.3 and 65. That gives us 64.82 meter per second. That means if this is our ux, we can now get our t, which is the time of flight, equals to r over 3, which is 70 divided by 64.82. Now don't forget the question that we should show that the time of flight is equal to 1.08 seconds. So from here we want to show if truly the time of flight is 1.08 seconds. So 70 divided by 864.82. If you see it's 1.0799 and this approximately 1.08 seconds. So from the first question that we should show that the time of flight is equals to 1.08 seconds. From there, you know, I will say that our horizontal range, which we denote as r, is equals to the horizontal component of our velocity times the time of flight. From there, we get our time of flight to be 1.08 seconds. The second question is saying that we should calculate the height of the center of the target. That means this height above the ground, the height from here. Don't forget that the height above the ground here is 1.66, so that means here is also 1.66. But we are looking from here to here. That's the height we are looking at. And don't forget, from our upward motion, downward motion, this target does not go back to the same plane at which it was projected. Do we still remember when we have a projectile motion? This is what we are saying. So from the point of projection, the plane of projection, that we have a projectile moving in this form, it comes back to this point. And that is where we can say from here to here is our maximum height, while from here to where is our range. Now we want to get this point now. Because it does not come back to the plane at which it was projected, which assume that the height becomes 0. Now this is upward. Don't forget from our equation of motion, we have x equals to ut plus half at squared. Now for the upward motion now going, that means our x will be equals to the vertical component of our velocity, uy times t minus half gt squared. Now the time we are talking, as we are talking about projectile, the time here becomes our time of flight. That our x will now be equals to uy t minus half gt squared. Don't forget our g is a constant, 9.81 meter per second square. 9.81 meter per second square. Don't forget that we use this to prove the formula for the time of flight, because we assume that the height here, since it is coming back to the plane, is 0. But here now, it is not coming back to the point at which, to the plane at which it was projected. That means it has hit its target down. So this x cannot be 0. So that is what we want to look for. Now, but don't forget, we know that the total height here is 1.66 meter. So that means let's look for our vertical component of our velocity. Our uy equals to u sine theta, and that will be 65 sine 4.30. So if you punch that in our calculator, 65 sine 4.3, that gives us 4.87 meter per second. Let's substitute it so that we know what this height will give us, and what we get here, we just subtract it. Now that means my x will now be uy, which is 4.87, my time of flight times 1.08 minus half times 9.81 times 1.08 all square. That means my x will now be 1.08 multiplied by 4.87. So that means 5.2596 minus 1.08 square multiplied by 9.81. I say this one is just multiplied by 0.5. 0.7212. So if you now subtract it, you will see that this thing is leaving us to minus 5.2596 minus 5.7212. So this is minus 0.462. So if to two decimal places, I can say it's approximately minus 0.46. Now, why this minus? Why this minus? Don't forget that when the arrow is coming, it hits its target. What this one is saying that from here to here is this. That's why it's giving us the minus. So what will be our height downward? So the height above the ground, the height of the target above the ground will now be 1.66 minus 0.46, and that will give us 1.66 minus 0.46. So that will give us 1.2 meter. Please, if you are new to this channel, don't forget to click that subscribe button and help us to share it to any of the students out there that you know this thing will be of benefit of. Thank you.